Good morning, students. Welcome to today's session on the applications of called solar cooker with the course Renewable Energy Resources under the course for 21EE652. Myself, Dwarkanath SK, Assistant Professor, Department of EEE, SJBIT, Bangalore. So let's go into the topic of discussion, application called solar cooker. So in the pic you can see the solar cooker on the mid part of it. There we can keep the utensils or vessels for cooking purposes, which is surrounded by a solar based collector, we call it. The mirrored surface with the high specular reflection, which is used to concentrate the light from the sun into a small cooking area. So depending upon the geometry of the surface, sunlight this can be concentrated by several orders of magnitude, producing the temperature of high enough to melt that particular salt and metal. So such high temperatures are not really required for the most household cooking applications. So solar cooking products, they are typically designed to achieve the temperature in the range of around 65 degrees centigrade. We call it as baking temperature, and 400 degrees centigrade for the grilling temperatures on a sunny day. This light energy is then converted into the heat energy. Solar cookers, they concentrate sunlight onto a receiver such as the cooking pan. So this light energy is then converted into the heat energy. So solar cookers, they concentrate the sunlight onto the receiver such as the cooking pan. So this interaction between the light energy and the receiver metal, which converts the light to the heat, and this is called as the absorption. This conversion, this is maximized by using the materials that absorb, conduct, and retain heat. Pots and pans are used on the solar cooker that should be a metal black in color to maximize the absorption part of it. So moving on to the next slide. So the basic operation of a solar cooker, how it works is, here if you look at the particular figure, sunlight which is coming and falling on this mirror, and this is the focal point over here which is being concentrated at this particular junction. So the overall structure is being here supporting for the cooking pot. We are having a parabolic kind of mirror setup, and this is a rack for holding that particular pot and the mirror. So we use a solar cooker for cooking the food by using the energy which is radiated by the sun. Solar cooker, this works on the principle that sunlight that warms the pot which is used for cooking the food. Now this warming of this pot occurs by converting this light energy to the heat energy. Conve Concave mirrors, they are used in these types of cookers because these mirrors reflect sunlight into a single focal point. This point where we have kept the cooker over here, this is the focal point we are talking about. Here the mirror, this focuses sun rays onto a receiver such as the cooking pan. So a solar cooker lets the UV light radiation which is incoming from the sun, and then it transforms them into a longer IR or infrared light rays which that cannot escape. So radiated or infrared radiations have the energy to make the water or the fat and the protein molecules in the food vibrate energetically and heats up. This process by which the interaction between the light energy and the receiver material which turns light to heat is called as a conduction. So we can maximize this transformation by making use of the material that can conduct and retain that particular heat, so for a longer duration of time. So the basic working principle by making use of the mirrors to focus the sunlight. So to make cooking using the sunlight more effective, a mirror with a highly reflective surface is employed. This mirror, it concentrates and directs the sunlight into a small cooking area. By doing this, we can greatly increase the intensity of the sunlight, reaching the temperature high enough to melt the condition. So temperature achievable range is here in the range of 65 to 400 degrees centigrade. The second process over here is converting light to heat. Okay, so these materials of the receiver which transforms this light energy into heat, through a process called as the conduction. To maximize this conversion, this material that conducts and retains the heat as well as that can be make use of it. So the pot and the pans in the solar cooker should ideally be matte black in color, so absorb that light as much as light possible. And we need to trap that particular heat, so to make sure we retain as much as heat as possible. So we minimize the effects of convection by isolating the air inside the cooker from the external air, placing a glass lid on the cooking pot, which enhances the light absorption from the top and reduces the loss of heat to the convection. So the glazing material which captures the incoming sunlight, but it is opaque to the infrared thermal rays, and which improves the cooking ability to hold the heat. I hope the session was very much useful. So do subscribe to our department channel for more such videos. Thanks for watching. Any queries with respect to today's video, you can write down at workanath@sjbt.edu.in. Thank you one and all for watching the video.